Thank you for joining me today. My name is Ken Winterberg. I am the Technical Marketing Manager for the Business Continuity and Disaster Recovery products here at VMware. So my role is to create content like our What's New documents, the Evaluator's Guides for SRM, things along these lines. And it's my pleasure today to talk to you about Site Recovery Manager 5 and some of the new features and some hints and tips for you as you start taking a look at Site Recovery Manager 5 and things like vSphere, Replication, and so forth. So before I get started, how many people here are already using Site Recovery Manager of a previous version? So you're quite familiar with the features, that's great. How many people are not using Site Recovery Manager at all, just here to find out a couple of details? Okay, so it's a pretty even mix. So I'll spend a little bit of time explaining the new features in the context of the old features as I go through this. And I'm going to try to leave some time at the end for Q&A, but by all means, if something needs clarification as I go through it, throw things at me to get my attention, because otherwise I'm just going to carry on listening to the sound of my own voice. So, Site Recovery Manager 5, what's new? Recommendations for success. One of the interesting things about SRM is that it doesn't fit anywhere in particular in terms of the virtualization journey. It's not something that I say, oh, you have to do it absolutely first thing. It's not something that is a requirement for cloud computing or anything along these lines. Business continuity, disaster recovery is an important aspect of any environment, virtual or otherwise. So this is something that you can really take a look at validly at any point during your virtualization journey. So what does Site Recovery Manager do? Well, it's designed to help automate, centralize, and make better your disaster recovery planning and your business continuity planning. So vSphere has at its core some capabilities in terms of protection. We've got things like vMotion and Storage vMotion to help us avoid unplanned planned outages at our local site. We've got HA to help recover very rapidly from failures that we have not planned, and things like fault tolerance to help build this up almost like a protection matrix to help us protect our virtual machines through unplanned hardware failure without any outages. And the idea of Site Recovery Manager is that we can then expand this matrix of protection to include the entire site or a subset of the site for a partial site failover or application level failover between environments. So Site Recovery Manager is really designed to take what used to be manual processes. We used to have runbooks where we'd need to train our users on what to do in case of a failure. Those runbooks needed to be managed. We needed to train our users. We needed to continually update these if anybody introduced change into the environment. Even if they just changed an IP address, we would need to update those runbooks and retrain those users. And of course, users are all gung-ho when they first start. They read it and they say, yes, I've got my BCDR runbook and I understand it. And by the time they hit their 3 years, they're like, I'm not reading that anymore. I don't care. So we can centralize this. We can digitize this. We don't need to make extensive changes to the way we train our users. We don't need to update these different runbooks because we now have this all in one central location. And SRM is designed to be the orchestrator, the tool that helps us not only plan for recovery, but give us one location to actually manage our recovery and even more importantly, test our recoveries. So the testing aspect of SRM is absolutely huge. This is how we guarantee that our environment will run and will run correctly in case we experience some sort of a failure. So simplify it. Make it cost efficient and automate things is really the trinity of what Site Recovery Manager does. And the new features I'll be talking about today all fit into one of these areas because these are the critical components of business continuity and site recovery. So I have a few different areas that I want to talk about today. The technology changes, so some of the core pieces, you've probably heard about vSphere Replication at this point. That's a very major addition to Site Recovery Manager 5. Some of the scalability improvements, workflow changes, the user interface, and some other miscellaneous changes from SRM 4.1 to 5 that don't really fit into those categories, but they're very important on their own. So vSphere Replication. Traditionally with SRM, we've been very dependent on the replication that takes place at the array level. We act as the orchestrator. We can direct the arrays to replicate our virtual machines however we choose, but we needed the arrays to do that. We were very dependent on what we call a SRA, a storage replication adapter, to communicate with those arrays and direct that replication. That's fine, and it's a very, very good technology, and that model is still carried forward with SRM 5. We still use array-based replication. It's still, to a large extent, the premier means of protecting your environment using array-based replication. You have far more options. It's a more mature technology. But what's been the largest problem with array-based replication? Cost. It's expensive. Not always expensive, but it costs a fair bit. And particularly for small customers, for the SMB sort of market, they don't necessarily have another site, let alone multiple arrays and replication technology. So we've introduced vSphere replication. It's not a hardware-based replication. It's a component of the vSphere platform itself that is enabled by Site Recovery Manager to give us an option, an alternative way of replicating and protecting our data from one site to the next. So vSphere replication works as a combination of technologies. It's embedded directly within the ESXi 5.0 hypervisor, and it is called upon and orchestrated by SRM to offer this other means of protecting our virtual machines and replicating them from one site to another. It is irrelevant what the underlying storage is. vSphere replication operates at a SCSI filter level. So as a virtual machine writes to its VMDK disk, this filter will intercept that, track what changes are occurring, and then eventually when it comes time to replicate it, tell the ESX servers which blocks need to be shipped across the wire. Meaning, the storage arrays, the underlying platform for storage, never comes into the question in terms of how the replication works. It's entirely done at the hypervisor level. So we can use the new VMware VSA. If people have seen that, you're probably quite excited by that one. It's a free virtual array using RAID 5 and a couple of other technologies. We can use local disk. We can use NFS, SAN, iSCSI. We don't care. It doesn't matter. vSphere replication will work with any type of disk that we've got. Heterogeneous data stores. We can replicate from SAN on our protected site to local disk on the recovery site. Managed as a property of the virtual machine. In the past, as I mentioned, we use these SRAs, the storage replication adapters, to allow SRM to communicate with our arrays. Well, now, that made it a property of the array itself and a property of the storage platform. With vSphere replication, it's a property of the VM. We can right-click on a VM, choose the VMDKs we want to replicate, and that is now, choose the recovery point objective for that virtual machine's disks, and that is now a property of the VM itself. So we set it as a policy for the virtual machine and then allow the platform to handle making sure that the RPO that we have set, the recovery point objective that we have set, is being met for that VM, rather than having to worry about managing our storage layer to get to it. And it's very efficient. We're not doing anything in terms of altering the way that virtual machine is being processed. We're not snapshotting the virtual machine. We're not injecting different system calls into the operating system. The VM is completely transparent to the virtual machine. There might be a couple of % overhead on the CPU if it's a very busy virtual machine that's doing a lot of changes, because obviously we now need to track all of that and replicate it. But from a virtual machine processing perspective, it's no different. Now, my first recommendation, if you are using array-based replication, you can absolutely use vSphere replication as well. Array-based and vSphere replication are completely independent of one another, and they can both be utilized in the same environment quite happily. They augment each other. It's not a replacement, it's an augmentation. But don't use vSphere replication on virtual machines that are sitting on array-based replication. And there are a couple of reasons for this one. Any ideas why? It's a waste, first and foremost. You're now replicating the same data blocks twice over. But it also impacts how we can create our recovery plans and our protection groups. If we now have a virtual machine that's sitting on a replicated array disk, chances are good that that's in a protection group and that's now part of a recovery plan. Well, if we fail over that LUN or whatever data store it is, the protected virtual machine that we're using with vSphere replication is also failing over. So now it's going to be replicating from itself to another copy of itself on the remote site if it works at all, which it wouldn't. So forget that. So keep them logically separate and physically separate in terms of where we put our virtual machines if you're going to use vSphere replication. Okay. First recommendation for this. Seed the environment is another one. So with vSphere replication, the way it works is the initial replication that we configure for our virtual machine, the primary disk and the recovery disk, it does a comparison. It'll check some of the blocks of the primary VMDK and the secondary VMDK. If we have not replicated anything, then obviously it's a fairly easy comparison. We know that we need to replicate the entire virtual machine over to the secondary site. But we can seed a copy of that VM at the remote site through any mechanism we want. We can copy it on disk, we can export it and import it. You can take a file that looks kind of close to your primary VMDK and say that that is the seed, that's the target for our vSphere replication for that virtual machine. So the initial sync, when we set up this replication, it'll do an initial full sync, and it'll compare the checksum of every block on both files and ship over the blocks that it knows it needs in order to bring the VMs into alignment. So we can seed it and save a ton in terms of the bandwidth necessary for that initial full sync. So if we can get that data over there through any mechanism you choose, it's a really good way to speed up not only the amount of time that it takes to get into synchronization, but it will reduce the bandwidth, ultimately giving you a faster time to protection with your environments. Yes, there's a question. The question is, if you're already using array-based replication, can you stop using array-based replication, then point to that? Yes, as long as it's a VMDK file, we can use that as a seed. Yes, absolutely. You would not want to, you'd want to make sure you then don't re-enable replication on that because you're going to be overwriting your system. So it will keep these two sides in sync continually. If it loses access to that VMDK at the recovery site for any given period of time, it's fine. We'll still, in essence, cache the blocks for writing until that VMDK comes available again. But ultimately, we might do another full sync if we can't gain access to it again. So even if you lose that disk that you're holding your copy on, it will eventually do another full sync and replicate that data again. Be aware of some of the limitations. We'll talk about this. vSphere replication is a very cool technology, but it doesn't fit every single need. The biggest barrier, I would say, is this 15. Oh, the biggest barrier is my laser pointer doesn't work. I'll have to use my words and my fingers. 15 minutes to 24 hours. Our recovery point objective is obviously one of the most important aspects of any recovery, any sort of environment for Site Recovery Manager, for any sort of BCDR. The maximum we can get in terms of our recovery point objective is 15 minutes with vSphere replication. So this is probably a fairly obvious thing for those of you who are using this already. Array-based replication, you can get 0 minute. We have complete synchronous replication with arrays. 15 minutes is the fastest we can get. And it's really a drop-down or a slider in the interface to choose between 15 minutes and 24 hours. So this brings to mind again, where does vSphere replication fit? It's really, it's great for the SMB market that can't use anything, but it's also good for the enterprises that are using array-based replication already, but can't necessarily justify putting every single virtual machine we've got onto expensive replicated arrays. Well, you can augment that, create a secondary tier of replicated protection using vSphere replication, but be aware about the 15-minute recovery point objective. And also don't just go crazy and say, great, 15 minutes, and then set every VM you've got to 15 minutes. It's a dynamic protocol. It will actually adjust itself based on how busy the changes are to disks. So we track not only the changed blocks, but how rapidly it's changing. And we make it more aggressive in terms of what it will ship across the wire if there are more changes being made. So if I set this system up and I say 15 minutes, that's great. And I can meet that during normal conditions, but then that system gets very busy and there are a lot of blocks being changed on disk. I might be in danger of not meeting that 15-minute RPO. And if I've set all of my VMs to that 15-minute RPO, unless I have a very, very static workload in terms of the churn rate of my data, it might impact a lot of things, as well as your bandwidth. So use it cautiously. Use it where it makes sense. It's not a panacea. It doesn't replace anything. We still have the same considerations in terms of replication speed and all the rest of that. And snapshot limitations. We can work quite happily with snapshots. That's not a problem in terms of vSphere replication. Your primary VM can have, dozens of snapshots hanging off of it and run in snapshot mode for 2 months. That's always a good practice. I'm kidding. Don't do that. It's very surprising, actually, how often people. I'm not here to talk about snapshots. Don't run your VMs in snapshots. Now I just said something stupid there too. You can use them. Snapshots are supported. We can absolutely replicate virtual machines that have snapshots hanging off of them at the protected site, but those snapshots are not represented at the recovery site. We just aggregate that all into a single VMDK, we collapse it all down. So be aware of that. If you use snapshots for anything abnormal, like other than just sort of temporary testing and things along those lines, those snapshots will not be represented. The data will be there. We still just, we do change block tracking. In essence, we figure out which blocks need to be replicated, and we just pipe it into that VMDK. So the changes are there. We're not losing any data, but it's still something to be aware of. Yes, there's a question. Yes, if you're running in a snapshot mode on the primary, we are writing that into the VMDK at the secondary. Now, if you remove that snapshot, what's going to happen? A whole bunch of blocks have changed all of a sudden, so now we're going to replicate that to make sure that it looks that way. And be aware, if there's enough that's changed that we can't do very standard types of things and it looks different enough to vSphere replication, it will do another full sync. So that's why I think this is an important one to be aware of. The question is, well, that's a twofold question. The question is, are linked clones supported? And the second question is, going forward, are linked clones supported? And I think you probably can guess the answer to that. Currently, no. In the future, hopefully, yes. So that's my recommendation in terms of this. The user interface for vSphere replication is pretty snazzy. It's a property of the virtual machine. So as you can see at the bottom of the screen here, it's really, you can right-click on a VM, select vSphere replication, choose the RPO and the source and the destination for that virtual machine's replication settings as a property of the VM. So it's very nice to have. Now again, we can run this in conjunction with SRAs and array-based replication, so it doesn't replace that. I want to be very clear about that. I've been standing at the booth and a lot of people are saying, so we don't need array-based replication anymore. You can use both, but be aware that if you're setting it for a virtual machine as a property of the VM, you should still be taking a look at where it resides and whether or not that VM is sitting on a protected data store at the array level. Use the right replication engine for the job. So we can access it as a property of the VM. We can also access this through the SRM plugin. We can go into SRM and configure our vSphere replication and go make changes there and manage it all through SRM as well. We don't have to do it in two different places. I just thought it's a really nice thing that we can also access it off the main hosts and clusters sort of tab on the vSphere client. Limitations. This is a SCSI filter. It consists of a couple of pieces. There's an agent and a filter that are on the ESXi 5.0 hypervisor. There are a few pieces of framework that we install that I'll talk about in a minute. But fundamentally, it's tracking the blocks as they are being changed, which means it's really only going to make sense for a powered-on virtual machine. So with that in mind, ISOs and floppies won't be replicated. Powered off or suspended virtual machines will not be replicated. So we can configure vSphere replication for powered off systems, but nothing will happen. It's not going to copy anything until it's powered on and starting to drive I/O. Things that sit in this directory with the VM but are not a protected VMDK will not be replicated. So all the logs and the swap and all the rest of those things, that's usually a good thing. We don't want to waste our bandwidth on things like swap files. Device layer, I mentioned the snapshots. We talked about that. Physical RDMs will not be supported. Virtual compatible RDMs are supported because, again, we've at least got that, that driver that we can work with at that level. Fault-tolerant linked clones templates will not work at this point with vSphere replication. Question?
When you say physical RDMs are not supported, is it just that the physical RDM will not be replicated, or is it that you can't even enable replication on a machine that has, like if you have a machine that has two VMDKs and a
Yes.
physical RDM,
Yes.
can you still enable it just to get the VMDK?
Absolutely. So the question, and thank you, I forgot to mention that earlier on. The question is, well, physical RDMs are not supported. Does that mean a VM with a physical RDM cannot be replicated, even if it's got other VMDKs? No. We can absolutely replicate VMDKs regardless of whether there's a physical RDM there or not. And in fact, we can choose an entire VM and just right-click on it and say vSphere replication and let it go and choose a target for it. Or we can choose a subset of the VMDKs within that virtual machine. So if it's got 5 VMDKs and we don't care about 3 of them, we can just choose the 2 that we want. Yeah, thank you for that. I mentioned try not to mix and match VR protected VMs with array protected. It'll work. You're wasting a lot of cycles. And this is one I didn't refer to earlier. We have a new feature called reprotect and failback. Well, 2 features, reprotect and failback with SRM 5. Those will only work with array-based replication. It's a function of the SRA to set up an automatic reprotect, and I'll talk about that in a couple of minutes if I hurry. That only works today with array-based replication. It's a function of the SRA that we call, rather than a component of vSphere replication. So that's another reason why it's important not to mix and match these things. If our recovery plan includes both vSphere replication and array-based replication virtual machines, the failback will work and it'll look great, and all your vSphere replication VMs will error out and cause all sorts of problems. Yes? They end up as VMDKs. Yeah. Yeah. We create a VMDK at the remote site. That's it. Virtual hardware layer, it's not the ISO layer. ISO 7 is required. What? Virtual hardware layer 7. Okay, next slide. 7 or later for our virtual hardware. Okay, so this is the architecture of SRM 5 with vSphere replication. So you can see that things haven't changed. We have the same architecture that we've always had, an SRM server, the vCenter server, the plugins, the vSphere client, and so forth. If you have array-based replication in SRAs today, that's fine. It all still works. The new additions are 3 pieces. I've mentioned the framework. So the VRMS and the VRS are virtual appliances that we deploy and configure through SRM. So there's not a lot of configuration that we need to do. You give it an IP address and a root password, that sort of thing, and away we go. The VRMS is the vSphere Replication Management Server. So this is the piece that controls and coordinates all of that replication that we're going to do through VR. So when I set the policy for replication of a VM for a replication, it communicates with the VRMS. That's what tracks all of the different replication policies, where I've got the VRS, where I've got agents that are or ESXi hypervisors that are ready to run that. It does not partake in the replication itself. It just coordinates it. It manages it and acts as the director for it. It has its own database as well. So that's a new addition. We need to create that database. It's not an integrated one. The VRA is the vSphere replication agent. That is the piece that actually tracks the blocks that change. And the way this works is that we select the policy for a VM for replication. The VRMS then handles setting up that, what that should look like in terms of the replication. And then the VRA is what tracks and filters that I/O as it goes down to the VMDK. It does, in essence, a form of change block tracking. It's not using the vSphere CBT. It's actually an older technology than change block tracking. But we keep, in essence, a bitmap of dirty blocks. And then as we set our RPO and we start climbing through time towards the end of that RPO, we will ship those blocks that are necessary in basically a bundle of blocks that are together. So if we've got a handful of VMDKs that we're replicating, we group the change blocks together so that they are consistent with each other within that virtual machine. We bundle the change blocks and we ship them across the wire. So it's an ongoing replication engine. It's not a schedule. We don't say, okay, we've got a 2-hour RPO, then every 2 hours we'll ship blocks. It's an ongoing trickle of blocks as it checks through the replication cycle to see if we need to accelerate that replication in order to meet that RPO. Does that make sense? As things change more frequently, we ship more blocks on an ongoing basis, checking all the time to make sure that we're going to meet that RPO and adjusting that replication cycle as needed. So we're not caching the blocks. We're not holding aside a copy or anything like that. We're tracking what has changed, and then according to our algorithms for VR, we will ship those change blocks, a copy of those change blocks on the fly. So it's not taking extra disk space. We're not creating an extra area to hold the changes or anything along those lines. It's just a bitmap of change blocks. Hang on for 1 second. So when those blocks get shipped, they go straight from the ESXi server, from the VRA, to the VRS at the recovery site. We only need one VRS per site that is a target for replication, but we can have more than one VRS to help scaling. So as we need more target servers, we can just scale up more and more VRSs to receive those blocks and distribute those writes out to the ESXi servers, which then write it out to the VMDK that they're holding. Yes? Not really. It's within a VM itself. So if a VM has one VMDK, then we'll just ship the change blocks as we need to. You still create a little bundle for it, and then we just ship that bundle. If they've got multiple VMDKs within it, then that bundle will be, to some degree, a similar sort of concept, where the VMDK change blocks will all be replicated to the same point in time within the VM itself, though. So we don't do that with a whole bunch of VMDKs. You can't set a folder for consistency or anything along those lines. We just say we want to make sure that all the VMDKs within a VM are replicated together so that it's self-consistent in terms of the sets of VMDKs, but not any broader than that. So the VRS receives the change blocks, passes it off to the ESXi server, which then writes it out, which means we now have a consistent system. It uses, I can't recall, it is a, it's getting late in VMworld here already, man. It uses one port for full sync, it uses another port for replication, and it is a, I don't know. I've got that in my frequently asked questions. And so this reminds me, we have a frequently asked questions document that I'm writing up. That will be released relatively soon. SRM Evaluator's Guide, where I outline walking through all of this stuff, that will be released soon. And a bandwidth recommendation and architecture white paper being written by Lee Dilworth, for those of you who are familiar with it. And that will be coming soon as well. Bandwidth is tough to estimate. Everyone wants to know, how much bandwidth do I need? What's the latency going to be like? All the rest of these things. I can't tell you. I really can't. Because it's dependent on two things. One, what's your data churn rate? How many VMs do you have? What's the data change rate like? As well as what's your RPO? So if you've got a really busy system and a 24-hour RPO, it's not going to take a lot of bandwidth. If you've got a busy system and a really tight RPO, it's going to take a lot of bandwidth. If it's a lot of change on all of your VMDKs, it's going to take a lot of bandwidth no matter what. So I can't really answer that. We're working on this white paper that will include some sort of industry standards in terms of change rates. So a standard 5,000 mailbox exchange server will likely use this on average, but that's really what we can get to. I'm sorry? 8095, 8096, 9007, 9000. You've got my document there? Okay, cool. Oh, okay. What was that, TCP or UDP? Does it say TCP or UDP on that? Yeah, okay. I'll follow up with that and make sure that you get that information. Scalability. Some of the scalability limits for version 5 have changed. Some of them have not. The key thing here, I think, is we have 1,000 virtual machines per instance of SRM, of which 500 may be vSphere replication. So we can have a maximum of 500 virtual machines replicated with vSphere replication, 1,000 total. The cool one here is the simultaneous running recovery plans is 10. So in the past, we could do a handful of things in terms of interleaving our recovery plans, but there are still maximums. 10 running recovery plans simultaneously running at the same time means that we can restart a whole bunch of virtual machines in parallel. This is a really nice addition. This was up from, I think it was 2 or 3 in the past. But 10 simultaneous running recovery plans is awesome. So we can dramatically reduce the recovery times that you get by doing things massively parallel. And we've changed a whole bunch of things in terms of the start sequences and various other things. The maximums are not enforced, but please use caution. Only exceed those things if you've done extreme amounts of testing and that you can ensure that it's going to work in your environment. We didn't want to put an artificial cap on in terms of the total number of virtual machines or vSphere replication, but we can only do so much in terms of supportability and quality assurance and all the rest of these things. So this is where we stand today. So use the simultaneous recovery plans, but be careful. If we're now running 10 recovery plans, each with 5 protection groups, and each of those protection groups has dependencies defined within it, it can get very complex very rapidly. So use the simultaneous recovery plans, but also keep in mind we've changed the way we do start sequences within VC. We used to send out 2 start orders to Virtual Center per ESX host. So we could start up to 2 virtual machines at the same time on up to 10 hosts. So we could start 20 at once. We've changed that now. We just tell a Virtual Center, I want to start these VMs. and let VC handle how it wants to do the start sequencing. So if your host can handle, your clusters can handle starting 300 VMs at the same time, and VC, it's not going to violate admission policies or any of the rest of the stuff, VC will tell it to go ahead and do that. So that's, again, fantastic. 10 running simultaneous recovery plans, as well as this massive parallel start sequence for our virtual machines is great. Anyone see the problem with that? The potential problem with that is that we can really massively overburden those systems if we do so. VC will handle that, but if we start experiencing delays because we've introduced a whole bunch of parallel activities, that might throw off our dependencies. That might throw off the start sequences of virtual machines if we're all of a sudden waiting for another virtual machine to complete just because it doesn't have resources. And then we start something that shouldn't start until that one's completed and so forth. So use it with caution. And we'll talk about priorities and recovery plans in a second. Priorities and dependencies in a second here as well. So workflows. In the past, we had two types of workflows. We could run a recovery plan in test mode, which is a good thing to do, and we can run it in disaster recovery mode. We've introduced a new workflow called planned migration. Most of our customers did not use Site Recovery Manager for disasters because, thankfully, most of our customers don't experience disasters on an ongoing basis. But planned migration was the #1 use case with SRM, taking a set of applications and moving them from one location to another in a controlled fashion. So it's got a slightly different goal than a disaster recovery model. A DR event has as its goal a very, very fast RTO, recovery time objective. So when we experience a disaster, we hit the panic button, we want it to go and just start and get those systems up and get us back in operations as fast as possible. Planned migration has as a goal data consistency. By its definition, we want to lose nothing. It's a migration, not a failover. So we've introduced this workflow that does the exact same recovery plan, the same steps as in the recovery plan. We'll synchronize the storage, we'll shut down the VMs, we'll do another synchronization of the storage, we'll follow the same sequences and dependencies and so forth that we have. It's the same recovery plan. We don't need to manage it any differently. But it will stop in case of any error. So if we haven't completed synchronization and it tries to run a start sequence, it will stop. If a VM hasn't completely shut down and tries to carry on, it will stop. So it errors out and says, there's a problem here. It gives the administrator a chance to go fix those problems, make sure our applications and data are consistent, and then you can run the recovery plan again and it will carry on where it left off. So we can run those recovery plans over and over and over again. If errors are encountered, it stops, we carry on, run it again, and get a successful run. As opposed to a disaster recovery event, which carries on running no matter what. I can't shut down my VMs. I know, I don't care. That's because they're in a smoking crater. Just do it. So, for those of you who have had smoking crater data centers, I apologize for being glib. It's not fun. New workflow as well, Failback. So I mentioned reprotect and Failback earlier. Who's done a reprotection and and a Failback with SRM 4.1? Couple people. It's fun, isn't it? Isn't it great? That's. Could you just use a word to describe the process? Is it exciting? Painful? That one comes up again. Okay. Again, everyone is far more polite than I am in my own head. So the process for recovering, for doing a failback in 4.1 and earlier, is basically to clean up, delete everything, go talk to your storage admin, get him to reverse the direction of replication, go back, recreate your protection groups or recovery plans, run it, and then find out that there's a stub somewhere that didn't get cleaned up, and then you swear and cry. You go through, you clean it up again, you carry on. Reprotect is a single click in SRM 5. After you've run your recovery, whether it's a DR or a plan migration, doesn't matter. It completes its synchronization, the power on sequence, everything's good. You click reprotect and you walk away. Well, maybe not walk away. You check to make sure it works. It's a function of the SRAs now. The SRAs in the past did about 4 things. Now they do 22 things, including things like reprotect. So it reverses the direction of replication of the arrays automatically. We say we have failed over, the primary site's now back in operation, you click reprotect, it'll go out, communicate through the SRAs to the arrays, reverse the direction of replication, make sure everything's protected, it comes back and says great, and then you can do a failback. So the failback is really a process, it's a sequence of steps. It's a failover, a reprotect, a failback by running the same recovery plan that we used in the past, and then a reprotect again. That's an important sort of 4th step to ensure that we're now reversing the replication and protected again back from the primary back to the recovery site. So it's this process of migrating to one site, clicking reprotect and then using it to fail back to the primary. Again, after we've done it, it only works with an SRA, meaning it only works with array-based replication at this point. That's coming. We'll work on that for vSphere replication as well. And the other key thing here that you need to be aware of, well, first of all, we can use a disaster event to fail over, and we could use a planned migration. Most likely would use a planned migration to migrate back. We can mix and match. It doesn't particularly matter. But the fail back is really just running the same recovery plan that we use to fail over. So it's the exact same recovery plan. We're just click run on our recovery plan and carry on. So anyone see the problem with that? Absolutely. The question is, does the failback work if you're re-IPing on the failover? Absolutely, and I'll show you why in a minute here. So the problem with doing this as part of this running the same recovery plan is how long have we been running in a disaster mode? Have I introduced new virtual machines? Have I changed things? Have I done a storage vMotion? All the rest of those things while I was running in recovery mode or on the recovery site. Perhaps if you've been over there for a couple of months, very likely things have changed. Well, that recovery plan won't reflect that. We might have to revisit our recovery plans. So keep that in mind. If you fail over, you reprotect, you run the recovery plan to fail back again, you go, awesome, you might have left something behind. So be careful with that. So this is the process. It's a failover, it's a failback. One of the neat things with SRM 5 is that we can now see not only our array pairs and our devices, but we can see the direction of replication within it as well. So it's a very easy thing to go through and check, and I do this personally, probably a little bit OCD-ish. I go in and I check my direction of replication just to make sure that everything is pointing in the right direction. So when I run a test failover or a real failover, that I'm actually failing in the correct direction. But we can see it very quickly and very easily just by taking a look at that arrow, which site is which device replicating to. And always check it before you run a test or a failover, unless there's fire burning you need to panic and hit the button. So check the direction of replication. User interface changes. Previously with SRM 4, we had to manage the different elements of SRM from different vSphere clients, or we need to connect to the different site, more to the point. So I'd have to go connect to my primary protected site, set up my protection groups and all of my array pairing and all the rest of those things, and then you go over to, you open another client and you point it at your recovery site, and that's where you set up your recovery plans. And I cannot tell you how many times I've forgotten to do that, and then I'm just saying, why can't I create a recovery plan? What happened to my protection groups? I'm like, oh, I'm just logged onto the wrong site. Then you go and you log onto that one. So the new UI is completely unified. We can do all of the administration for the entire site recovery manager infrastructure from one location, from one UI. So it's a beautiful thing. Everything is visible from that one location, whether or not we have linked mode. Doesn't matter at all. It's all visible. And that's a very, very, very good thing. Linked mode is still a great thing to use, though. Not only for ongoing daily administrative types of purposes for our systems, but in terms of license management. If we can share our SRM licenses very easily and they will be accessible and visible through a failover and a failback and all the rest of these things without having to take the license file and input it somewhere else, it makes it much, much nicer. So still use linked mode, but be aware that we have a lot of changes here. So another thing within the new UI is that we can now see what our shadow VMs are. They are represented by an icon to show me what systems are being protected to this site. So if I have a shadow VM, which is in essence a stub that shows me what I am protecting at my recovery site, I can now identify it. I've got a handful of VMs that are being protected. These are the ones. They're represented with this lightning bolt icon. And we can drop those into a folder. And incidentally, that's another recommendation, not particular to 5.0. Create a data store, an isolated data store for your shadow VMs. You create a folder for your shadow VMs so that we can very easily manage that and identify it. The other question was about IP addressing. We can now manage as a property of the VM, you'll notice again this is a property of test WK1, the IP addressing for both the primary protected site and the recovery site in one location. Right-click on a VM, set the IP properties for it, and you're done. That's cool, eh? I mean, I'm Canadian, so that's cool, eh? So, very, very easy to set this. Now, that is beautiful, and it's fantastic that we can set it for both protected and recovery site. And back to your question, yes, and we want to set it for both the protected and the recovery site. I can just click on the property at the bottom that say configure IP addressing, And it'll pull that IP directly in from what it's running right now, but we should set it for both sites because now we can fail back. We can move forward and back between sites, meaning we probably want this set as a policy for both sites. The question is, can this do multiple NICs? Yes, absolutely. Yep. I'm sorry? Multiple IPs on the same NIC? I don't know. I haven't actually tested that scenario. The one I've tested is more the adding multiple NICs with different IPs. They're so easy to create in a VM. Sorry, we'll come back to that. So, thing of beauty, easy to manage, but do this as one-offs. Only use the GUI to manage these things. We still have the bulk import, the bulk export editing of the CSV, and the bulk import of IP information, which is a much better way to do that in terms of setting mass policies for these things, or policies for mass sets of virtual machines. IPv6 is supported across the board, even with vSphere replication, as long as the ESX hosts, or ESXi hosts underneath it support IPv6. We can use that with vSphere replication as well. IP customization improvements. So not only can we now set it for both protected and recovery site, not only can we do it through a GUI. IP customization in the past used sysprep and customization specifications. So if we did a bulk import, it would automatically create the customization specification. We would need to have the sysprep files in the correct location. And when we go to reboot that system at the recovery site, it would do the sysprep process, right? I use the same sort of terms in my head for sysprep as I do for other aspects of slow systems. It takes a long time to do a sysprep. Well, the good news is with this one, we've done away with customization specs altogether. We've done away with sysprep altogether. We use a VIX API call to inject the IP addressing directly into the virtual machine, which shaves off, I don't know, depends on the system and your processors, but let's say a minute, minute and a half, 2 minutes per VM. Per VM. Now think about that. Recovery time objectives, right? This is what it's all about. If we can make a simple change like this to take it down to seconds in terms of our IP customization speed per VM from minutes, that's a huge reason to upgrade right there. So I did some testing on this, and I can't tell you the numbers of the virtual machines. I had a very small recovery plan that sped up by 9 minutes, and I had a medium-sized recovery plan that sped up by 25 minutes. And that was using IP customization and 2 scripts that was running. And the way this works is also slightly different because we now do a pre-boot. It's a preparatory boot. We isolate that virtual machine that has to have IP changes. We boot it in isolation, inject the API, and shut it down as a first step of any recovery plan for systems that, well, as let's say the 4th step for a recovery plan that has IP changes. So that means when they go to start according to the sequence that we set in our recovery plan, they are now already customized in terms of IP, and they just need to start. So it's a very rapid process for IP customization and for recovery. Now, use the VMware tools. We need that in order to inject the API through the VIX API. It also helps speed up your time because now we don't time out waiting for the VMware tools, which we do by default. So use the VMware tools and everything gets much quicker for that. For extensive customization, again, the GUI is very nice to be able to set that for individual systems, but that's going to be painful if you've got 500 VMs that you need to do that for, and just use the GUI for one-offs. Good? Any questions? No? Excellent. Okay. If you make extensive changes to it, it will unprotect the virtual machine. Yeah. But it will be tagged, and it's just a matter of right-clicking on it and saying configure this thing. But that's really more if you're making very dramatic changes to it. Something simple like that, no, it'll be protected. I just realized I'm really running low on time, and I was getting offended everyone's leaving, but it's okay. Scripting. We can now use scripts within a virtual machine. We've always been able to call a script that resides on the SRM server itself as part of the recovery process. We can now call scripts within a virtual machine. So if you need to do operating system or application-specific customization, we can now do that very easily. My recommendation is only do that, again, where it's necessary. Don't do it just because you can. Because the problem is, scripts that sit on the SRM server, you've got one instance of them. That's easy to manage and change. If you put a script out to 500 VMs and you go, damn it, I forgot to close that bracket. and you got to go back and update them all again. And so where it makes sense, do it just for the application customization that you need. API, we've had a SOAP API for SRM for some time. We've introduced 2 new APIs, or really 1 API with 2 halves. It's different depending on whether you're calling a protected site or a recovery site. Great tool in terms of automation, speeding things up. We can even do things like API calls to start our recovery plans. A lot of people have requested as a feature an automatic detection of failure, and then we can kick off our recovery plans automatically when there's a failure. Anybody have an opinion on that one? I do. Yeah, I've seen enough backhoes just go, ching, oh, is that your internet connection? Sorry. That's a terrible idea. But we can call it through an API because that might be something where you've got rigorous testing yourself to detect whether or not there's a failure, and you want to be able to automate that. Dependencies. In the past, we had high, medium, and low dependencies in a recovery plan. High was great. Really important systems go into our high priority group, and then they start sequentially. One by one by one, and we wait until that's done. Then finally, okay, that's done. Then we carry on with priority groups, medium and low, and they just start at spam random order. We've done away with that as well. We now have 5 priority groups in our recovery plan, and all virtual machines and all virtual machines within a priority group will start in parallel. So if I've got 20 VMs in my high priority, in my priority group 1, I'll spam that out to my VC and say, please start all of these VMs in parallel, and like I said, we can now do that. And all those VMs need to be started before priority group 2 comes up, and then we start all of them in parallel and so forth. So that's great. Why did we do away with high priority sequential things? Because now we have dependencies within our priority groups. So I can set, again, as a policy of the virtual machine, dependencies on other virtual machines. So I start all of my infrastructure servers in priority group 1, that's fantastic, but this one particular, that's a poor example. I start all of my database servers in priority group 2, let's say. And one of them is dependent upon a previous one. I just set it as a policy of that VM. I go in here and I click that. It's it. This one needs to be started before this virtual machine will start. So we can now create a matrix for our start sequence for our virtual machines. I can create something that looks like this. Group 1 will have my master database. Group 2 has a database and an Exchange server. So group 1 must complete first, then both the database and Exchange server will start in parallel. Then we wait until those are both operational, then we start group 3. But the web server won't start until the app server starts, and the app server won't start until the database server starts, or completes its boot, I should say. How did we do this in the past? Here's another extremely painful mechanism. We needed to create, in essence, multiple recovery plans for every tier that we wanted. So I might have a set of infrastructure that I needed to start. And I might have 3 different recovery plans for those things, for that infrastructure, just because I needed to separate the start of some of those things. And then we'd have to run them in sequence. Well, forget it. We can now have fewer recovery plans and use the priority groups as logical containers for the sections of infrastructure that I want in terms of sequence, and then use dependencies to actually set the order for start sequence within that priority group. So we can drop the number of recovery plans we have dramatically if it makes sense. We don't have to drop our recovery plans. There's nothing wrong with having a lot of recovery plans. But this is a much more elegant means of doing this than we ever had in the past. Now, what's the problem with this? We've just gained a whole lot of time with parallel start sequencing and all sorts of, great, massively parallel transactions and so forth. If I set dependencies for every single system I've got, I've just made that useless. So use these things where it makes sense. If we are now waiting for every single VM, you go through, set dependencies for everything, you're going to wait a long, long time for your virtual machines to start, especially if I'm setting dependencies in every recovery plan I've got. So if I do this, very, very simple one, I've got 5 priority groups instead of 3. Well, that's already waiting a little bit longer between the different priority groups. And then I set 3 dependencies, that's fine. If I've got 10 of these things, that's a whole lot of wait times that I've got. So use this with caution. Use this where it makes sense. And application mapping in vCenter. This has always been problematic. How do you know what to put into your recovery plan? How do you know what protection groups make sense for that recovery plan? And how do you know what data stores you need to put into those protection groups? It's a painful process to go through and analyze all the interdependencies of your virtual machines and their application interdependencies, to leaving them together so that we can now start them together. How do we know that information? vSphere Infrastructure Navigator is a new tool in the vCenter Ops operations suite. It uses the VMware tools to, in essence, sniff the application interdependencies between virtual machines and show you a nice map where you can click on a virtual machine and see all of the other VMs and all of the applications that are communicating with that virtual machine. You can see it in a tabular form, you can see it in a graphical form, you can walk that tree to create your protection groups or your data store layout, more to the point, so that your protection groups and recovery plans make sense. So it's a new tool, very, very exciting. It's showing down at the ops booth downstairs. That is the summary of the new features. There are two things that I want to get to first before I let you go. I said before I let you go. Mike Laverick has a fantastic book. He's been a brilliant writer about SRM. You can get his 4.1 guide for free as a download, or you can buy it in book form. There's another one coming very soon. I've heard mixed things, whether it's coming out next week or in December. But look for Mike Laverick's book. It's going to be pretty much the definitive guide in terms of use. Fill out a survey for me. And this one is also very important. For those of you who are using SRM today and know the feature set and have some opinions on it, this URL goes directly back to myself and to the product management team. And you can have direct feedback about what's important to you and help steer the roadmap of our development of the product set. So I've got another 3 minutes or so before I have to take off. There's a question.
Yes, is there a way now to save recovery before you ban it, all that would go away, and you save
So history reporting is what you're talking about in essence? Like are you talking about a history reporting mechanism, or is it?
your actual setup of your recovery plan.
Oh, I see. Yes. So we can capture the recovery plan and all the information about that. We can export just about everything to an XML file. Yeah. So we can export that. The API call is the best way to do that. And that will dump it all directly into an XML file, which you can edit. That's right. Yeah. Yeah. There's another question right in front of you, though. If you moved a virtual machine, you mean?
Yeah, virtual machine moved from one data store to another
Yeah.
data store.
So
Protection group would come back and kind of
those who left are going to miss this.
how does that work with storage DRS?
Storage vMotion and storage DRS are not supported. Period.
So I can't use SRM and storage DRS.
You cannot use storage DRS and at storage vMotion if you want to be supported. It will work. It will work. But the problem is you might migrate it somewhere that is not protected. We can't guarantee that it's going to work. It works. It will work. It's not supported is the answer. It may be supported with vSphere replication. There's still debate about this, and we've got a few days to go before the product gets released. There's an indefinite amount of time before the product gets released. So storage vMotion may be supported if you're using a vSphere replication. But with array-based replication, it is technically not supported. If you move a virtual machine, you can flag an alert that says, hey, this thing is now sitting on non-protected storage. And you can go through and fix that. But if there's a failure during that period, you're not going to be protected and we're going to be in trouble. It depends, right? If it's on the same protection group, if those data stores reside in the same protection group, it'll be fine. If it's protected storage but not the same protection group, you can flag an alert on that, but then it won't work. Then you'd have to reprotect it and recreate it and all that stuff. Yeah. So I think there may be another session coming in here next. So I'm going to start walking towards the door, and I have to be downstairs for my next one in 5 minutes. So if you don't mind coming with me, and I can answer questions as we go.